Okay, so this problem is an Algebra 1 problem that looks at simple interest and how we can convert that into an algebraic expression in order to solve for two variables. This problem says Mary inherits $100,000 and invests it into two certificates of deposits. One certificate pays 6% and the other pays 4.5% simple interest annually. So we know that this interest, 6% and 4.5%, is reoccurring every year. If Mary's total interest is $5,025 per year, how much money is invested at each rate? So we have some portion of $100,000 being invested at a 6% interest rate and a 4.5% interest rate. And after the whole year, she has earned $5,025 in interest. So the first thing you want to do in these kind of problems is just kind of set up your variable names. So the first thing we're going to do is say we're going to let X be the amount that Mary, invested at 6%. So this is the amount invested at 6%. So then it would make sense to let Y equal the amount invested at 4.5%. And let's go ahead and write this. See in the problem it's 4 1/2 as an improper fraction, but or proper fraction, but we're going to write it as 4.5% because that's going to be easier to convert to a decimal representation of percents because that's what we can work with algebraically. So if we know that some amount invested at 6% and some amount invested at 4.5% will total to $100,000 because that's what she inherited and she invested it all into a portion of all of it into each one, then we know that X plus Y equals 100,000. So now we have an equation that relates the two variables. We also know that, well, let's go ahead and do this. What is 6% in decimal representation? Well, percent is out of 100%. So 6% is 6 out of 100. So 6 divided by 100, or we can just look at it as 6 with a decimal point at the end and move the decimal place 2 to the left. So we can write this as 0.06. This is the tenths place, this is the hundredths place, so this is the same thing as saying 6 out of 100. 6 over 100. That's the hundredths place, if that makes sense. And we're going to do the same thing with 4.5. So this is 0.045. We just moved the decimal place over 2. So the second equation, because we have two variables that are unknown, so we have to have two equations to relate the two because there's nothing we can really do with this. There's nothing we can do with this because we don't know what either one of them is, so we can only solve for one in terms of the other. We're never going to get a number representation. So here's what we're going to do. We're going to say, well, we know that 6% was invested at some amount X. So 0.6x plus 4.5%, 0.045y, that's the amount at 6%. The amount at 0.045%, if we multiply and add, we should get 5,025, right? Because that's the total interest that she got in a year. So this should be 5,025, right? Because 6% of whatever she put in at 6%, so 0.06x plus 4.5% at y should equal what the total interest in the year, okay? So there's two ways of doing this. We could solve this as a system of linear equations, but in case you've never done that before, something that might be a little more intuitive is saying, well, x plus y equals $100,000. So let's solve for y in terms of x and then plug it into this equation. So let's get one of these equations down to just one variable that we can solve for. So if x plus y equals 100,000, then we could subtract this x over, right? If we just subtract from both sides, so if we say minus x, well, that will cancel that x, and then this will leave us with 100,000 minus x. So this will give us y equals 100,000 minus x. So now we have y in terms of x, and we can plug it into this equation, right? So this gives us 0.06x plus 0.045y, but we're going to plug in what our y equals 100,000 minus x. It's the same thing because y equals 100,000 minus x, so we just plugged it in for y, and we're going to say that equals 5,025. Okay, so now we just have a simple linear algebraic equation with one variable that we can simplify and solve for x. And I'm sure you've done this before, but we'll go through it. 0.06x plus, what are we going to do here? We need to distribute this out so we can combine our like terms, right? So 0.045 times 100,000, well, that's just going to give us 4,500. And times 0.05 times negative x, that gives us negative 0.045x, right? And that still equals 5,025. So we have two x values here, two constant values here. So if we subtract 4,500 from each side, that gives us 0.06x minus 0.045x equals 525, right? And now these are both just x terms. So we have 0.06x minus 0.045x. So 0.06 minus 0.045, that's just 0.015x equals 525. And we just have to divide by 0.015 on each side to give us x equals 35,000. Well, what was x? Remember, x was the amount invested at 6%. So now we know that Mary invested $35,000 at 6%. So there's one answer. But how do we find how much she invested at 4.5%? Well, we have y in terms of x, right? Y equals 100,000 minus x. So all we have to do is say y equals 100,000 minus x, which is 35,000. So that gives us $65,000. And how do we know that's right? Well, we have two equations. If we plug these in, they should satisfy both equations. So is 35,000 plus 65,000 100,000? Yes. And if we plugged 35,000 here and 65,000 here, you would find that it does indeed equal 5,025. So you can always plug your answer back into your original equations just to make sure you didn't make some algebraic error in your manipulations. And you could also solve this using a system of equations. So let's go over that way really fast. So if we wanted to use a system of equations, so we had two equations, x plus y equals 100,000. And then we also had 0.06x plus 0.045y equals 5,025. So we have these two linear equations. Rule of thumb, if you have one equation, one variable, then you can solve for that variable. But if you have one equation, two variables, there's nothing you can really do unless you wanted to solve for one in terms of the other. Here we have two equations, two unknowns. So we can solve this. So however many variables you have, that's how many equations you need to solve. So if you have three unknowns and you have two equations, there's not much you can do. But if you have three unknowns, three equations, then you can solve for that. So here we just want to cancel one of these terms. So we have 0.06x and we have 1x here. So let's multiply this top equation by negative 0.06 all the way across. Now you have to do it to every term. So that gives us negative 0.06 x minus 0.06y, because the coefficients here were just 1. And then that equals 0.06 times 100,000. That's negative 6,000. And then we still have our second equation is unchanged. So let's just add these equations together, the like terms. So the x's cancel because that's a positive and a negative, and that's just going to equal 0. And then negative 0.06 plus 0.045 is going to be negative 0.015y, and that's going to equal, if you add those together, that's going to equal negative 975. That's an equal sign, not a negative. And then if you just divide by negative 0.015 on each side, it gives you y equals 65,000. And then you just substitute that back into any of your original equations, and you'll get x equals 35,000. So that's another way. This way is more intuitive to me. Two equations, two unknowns, just multiply by a constant to cancel one of them out, add the equations, and solve for the other. But that's basically what we did here, isn't it? I mean, that's basically what we did, just in a couple more steps. Either way, that makes more sense to you. You just have to do it the way that makes the most sense to you. And that's a simple interest rate problem.